Good morning and most welcome to 12:59 of the series. We are lucky enough to have a sunny day. I'm afraid I'm in no location to record the sun, but trust me, it is here. It's most welcome. I will continue in this episode with Roberto, Mangabeira, Unger and Lee Smolin's book, A Singular Universe. It is extraordinary what consequences this initially felt very small thing has. I'm now at page 149 of the extensive book. And the last thing in 1257 was the obfuscation and confusion of what it is to be explained and the way of explaining it. And this is exactly what initial conditions and permanent laws are. There is a confusion of the explanandum. And I would say that is not a philosophical problem. It is not a scientific problem either. While it has severe scientific consequences, but it is another type of problem altogether. To understand it and to see it takes thinking about two things at the very same time. And since Newtonian physics doesn't allow that, the problem cannot be easily dissolved or uncovered. It seems that the circumstances conventionally labeled the initial conditions of the universe cannot be explained by the standard explanatory moves of cosmology and physics. They are just factitiously here or there. The only way in which we could explain them would be to explain them historically, by the states of affairs that preceded them. Such an appeal to historical explanation is prohibited if, as the conventional technical view of the cosmological singularity supposes, the universe began in a limiting event of infinite density and temperature. Moreover, the frontier between the factitious stipulations and law-governed phenomena will be elastic. Whatever we are unable to explain, we can simply incorporate into a definition of the mysterious initial conditions. we may be tempted to escape our difficulties in applying stochastic reasoning to the explanation of the initial conditions of the universe by seeking refuge in deterministic explanation. We may try to redress our difficulties in deploying deterministic reasoning by finding succor in stochastic reasoning. However, the juxtaposition of two inadequate solutions to our problem will not provide us with an adequate one. If we now compare the deep reasons for the failure of the two forms of explanation, we can see that they are, in fact, two species of the same quandary. The difficulty results in both instances in the realm of probabilistic causation as well as in the domain of deterministic causality. From a misguided attempt to apply to the whole world forms of reasoning that work only when applied to part of it. The partiality is a condition for their success. These difficulties arising from the attempt to explain the whole by the methods with which we explain the parts. We must now add a second order of complication. Resulting from the special and surprising content of the initial conditions. The very hot initial universe might have been expected to turn out more irregular and entropic than it in fact has. repeat that because it's so important. To these difficulties arising from the attempt to explain the whole by the methods with which we explain the parts, we must now add a second order of complication, resulting from the special and surprising content of the initial conditions. The very hot initial universe might have been expected to turn out more irregular and entropic than it in fact has. From present observations combined with the laws of the Standard Model and general relativity, we can infer that the whole universe formed with a remarkably symmetrical geometry. The asymmetric movement of particles within the early hot gas barely perturbed this geometry. There is, for example, evidence that few black holes existed very early in the history of the universe. One way to state this point is to say that matter started very hot, but that the gravitational field began at absolute zero. Such a situation is very unlikely by the standard of the variations of nature within the cool-down universe. Had the initial conditions been simply random, the significance of this unlikelihood is to suspense. To strengthen further the reason to seek a larger context of explanation in which to make sense of the development of initial conditions with such characteristics. The simple application of the familiar forms of statistical and deterministic reasoning is powerless to solve this problem for the reasons just stated. There are then two large classes of ways in which we can go about solving it: plurality and succession. In the spirit of plurality, we take the universe formed in a cosmological singularity as one of an indefinitely large or even infinite number of universes shaped by similar traumatic events. To the extent that we explain the initial conditions stochastically, the large set of universes can in principle define the scope of the alternative states of affairs over which the calculus of probabilities will operate. The strangely and symmetrical and isotropic features of our universe, from its initial conditions on, can be dismissed as the consequence of its being an outlier among such alternative universes. Once we account for the initial conditions stochastically, and thus discount their improbable features, we can carry out the rest of our explanatory work by whatever combinations of statistical and deterministic reasoning the science of the day validates. The partial configuration spaces within which deterministic explanation applies will all have their ultimate origin in the particular initial conditions of our universe. If we are lucky, some of the laws, symmetries, and constants that we are able to establish will, by this reasoning, apply not just to our universe, but to all the universes. they will be compatible with different initial conditions for each universe, with a choice of initial conditions determined stochastically. The combination of the super universal laws with the accidental universe specific initial conditions will in turn generate the set of laws, symmetries and constants applicable to that universe. The reader may smile and imagine that he is reading a passage from Plato's Timaeus in updated vocabulary. In fact, this statement simply explicates and extends the direction that much of contemporary cosmology and physics has taken in its approach to the explanation of the initial conditions of the universe. The point of such pseudoscientific speculation is not to replace the standard ways of thinking stochastically and deterministically about the initial conditions, but rather to make up for their manifest inadequacy, to prop them up and make them seem more powerful than they are, given that we do not know how to replace these efforts at explanation. The alternative basis on which to understand the initial conditions is the idea of succession, interpreted as an instance of the thesis of the singular existence of the universe, rather than as an alternative to this thesis. The crucial point is that the formative trauma of the earliest moments of the universe remained at every moment within the realm of the finite, although very small space and universal time, flowing inexorably the one reality in nature that deserves to be considered sovereign. The significance of the finitude of each of the attributes of the events from which the present universe originated is that they permit a causal path through from the universe before those events to the universe after them. They suggest a way of accounting for the strange and improbable initial conditions of the universe on the basis of a historical explanation. The deepest complications presented by such an approach are twofold. The first complication is the difficulty of generalizing when the subject matter is a class of one. I think this is great. One universe, the one real world, passing through distinct stages or phases. The analogy to the physics of phase transitions fails because here we do not deal with a process that is local as well as a recurrent, and indeed recurrent under laws and symmetries that are stable in the cool down universe, even if they are not immutable. We reckon with events that, so far as we know, may never recur in the same way and with the same characteristics. The second complication is the difficulty of accounting for changes in nature so radical that they may be accompanied by changes in the laws, symmetries, and constants of nature. As a result of this second difficulty, we may need to abandon the assumption of a framework of natural laws that remains unchanged amid the changes of nature. Non-recurrence and change of the laws and other regularities define the form of universal history described by the conjecture of non-cyclic succession. A historical explanation may help account for the relative homogeneity and isotropy of the post-traumatic universe. Conversely, it may also help explain the way in which, as well as the extent to which, the universe displays asymmetrical and possibly non-Gaussian features. The question then arises whether such an understanding of the initial conditions of the universe is a mere speculative conjecture, or whether it can be developed, although from the starting point of natural philosophy, in a fashion that lays it open to empirical inquiry. It is a question vital to the force of our argument. I address it only in indirect and fragmentary fashion. Smolin addresses it directly and systematically. Two sets of observations and experiments would shed light on the respective merits of these two approaches to the initial conditions of the present universe. One is an approach relying on the conception of an infinite initial singularity, with its logic of infinite temperatures and densities, implied by leading interpretations of general relativity and of solutions to its field equations. Such an approach invites or allows elaboration by a cosmology of multiple universes, each of them causally closed and all of them causally unconnected to one another, with the qualifications implied by eternal inflation. The alternative approach reinterprets the formative events in the present state of the universe to ensure that they remain within the realm of the infinite. It therefore fits with an idea of succession. I suggested reasons to prefer non-cyclic to cyclic succession as the working assumption of research agenda. In this second approach, the causal nexus between the formative events of the present universe and events preceding them is shaken and stressed, but not broken by the violent origins of the universe in its present condition. The case for the thesis of the singular existence of the universe around us turns in part on the reasons to prefer this alternative view. One set of experiments and observations pertinent to the choice between these two views goes to the impossibility of generating any physical process that leaves the domain of the finite to enter the realm of the infinite. The emergence of a physical process with infinite rather than merely just very large quantitative attributes is so unlike anything that has ever been observed and suggests so radical a change in the workings of nature that we must ask through what transitions such a leap could ever take place. It presupposes that the radicalization of a physical process, its quantitative accentuation, will eventually reach a threshold at which it jumps into another realm of non-finite quantities. The quest for a perpetual motion machine was abandoned as the result of a combination of a repeated practical failure with a theoretical argument about why such an outcome was impossible. The failure to make such a machine, even under what seemed to be the most propitious condition, worked together with the persuasive force of the argument about the impossibility of perpetual motion in a world of friction, resistance and entropy. Similarly, we would need to persist in the experimental radicalization of certain physical processes to observe whether there is ever a sign in nature of anything that fails to lend itself to finitistic characterization and explanation. At some point, people will give up. A distinct set of experiments and observations would address the physics of the stressed and shaken, but not interrupted causal nexus between the events prior and subsequent to the extreme changes that lie at the beginnings of the present state of the universe. Observationally, we could achieve this goal by studying local circumstances in the post-traumatic universe that reproduce certain features of the traumatic events. Experimentally, we can try to mimic these conditions. A series of increasingly powerful particle colliders conceived by some in the service of the project of the final unification of the laws of physics under the aegis of the non-finitistic view of the cosmological singularities that is suggested by general relativity, can be enlisted in the service of this goal. Having observed or mimicked those fiery circumstances, we can see confirmation of the two conjectures that are central to this argument. About the initial conditions of the universe. The first conjecture is that the events and the structure subsequent to the trauma can be understood only in the light of the events and the structure prior to the trauma. The causal path through is real and indispensable to the understanding of the later event. The second conjecture is that the traumatic and extreme character of the formative events may not only change the laws, symmetries, and constants of nature, as the idea of non-cyclic succession implies. They may also generate a circumstance in which causal connections cease to exhibit a general recurrent, and therefore law-like form, because such observations or experiments will always deal with a localized part of the universe as a proxy for the universe as a whole, which we can neither observe nor tinker with. They will provide only fragmentary evidence. However, the accumulation of such evidence may throw light on a question of fundamental interest to cosmology. What combination of earlier states of the universe prior to the formative events of the universe in its present state, as well as of changes in the laws, symmetries, and constants of the universe, can help explain the otherwise inexplicable features of the universe in which we find ourselves. In this empirical effort, we shall find encouragement in the thought that one day our scientific equipment and ideas may enable us to discern more directly in our universe the vestiges of that earlier universe. nature in two moments of its violently discontinuous history, changing on a scale of time disproportionate to the scale of our experience. The unexplained constants of nature. A third controversy is the unexplained and precise values of a number of constants of nature, including the free parameters of the standard model of particle physics, as well as of the standard cosmological model. Consider the first problem in its most general form. We find certain constants or constant relations which we can describe as the parameters of a wide array of physical theories, omnipresent in the world. However, we do not know why they have the values they do. Their values appear to be brute facts, the unexplained furniture of the universe. Among them are the masses of the elementary particles, the strength of the different forces or interactions, the cosmological constant, the speed of light, Planck's constant, and Newton's gravitational constant. These values have so far defied all attempts to account for them on the basis of the laws of nature that we are now able to discern. Three of the unexplained parameters, Newton's gravitational constant G, Planck's constant h and the speed of light c are intrinsically dimensional. To the extent that they fail to vary, we can take them to define the units by which we measure everything else, including time, mass, and energy. Their function as part of the equipment by which we measure the world may give them some exemption from the query about why each of them has one value rather than another. However, the enigma of brute, irreducible facticity then attaches all the more strongly to the remaining unexplained parameters. These residual parameters are unitless or dimensionless ratios. The mystery of their having one value rather than another stares us in the face. In the dimensional parameters do vary, then the ratios of their values at different times are also dimensionless numbers, with the result that the mystery applies to them as well. With regard to the standard model of particle physics, there are 28 dimensionless parameters in addition to the 3-dimensional parameters. G, H, and C, giving units for counting quantities in nature. The problem presented by the pervasive presence of these surprisingly arbitrary values has two aspects. The first aspect is the special tuning riddle. Where the parameters, even slightly different, the might not have emerged stable nuclei, stable molecules, long-lived stars, or life, there seems to be no mechanism by which the teleological result could exercise causal influence. That is to say, no mechanism by which the indispensability of those particular values of the parameters to these outcomes can help explain why they are what they are. Some version of the anthropic principle, a reverse causal explanation appealing to the properties of a universe capable of accommodating us, then fills the vacuum left open by the failure of an adequate causal account. The second aspect is the fine-tuning conundrum. Many of the parameters are very small number. The constants are thus specified with a refinement that makes more disconcerting the absence not only of an adequate explanation, but also of any serious and sustained attempt to explain them. As mysterious as the parameters of the standard model of particle physics are the parameters of the standard cosmological model. This model works very well, at least back to nucleosynthesis, which is the time when neurons were created from protons and electrons in the plasma. However, it depends on additional unexplained parameters. Many of them also need to be finely tuned for galaxies and stars to form and for life to exist. Consider again the larger problem, now in the context of the enigma presented by the precise but unexplained values of the parameters of both the standard model of particle physics and the standard cosmological model. These parameters surface as constants in the cool-down universe. Did any or a few of them but slightly differ from what they are, everything would be different in the world. That the human race would never have appeared represents just another twist on this more fundamental enigma. The problem of the unexplained parameters or constants presents the puzzles of contemporary physics and cosmology from a distinct vantage point, and that is the perspective of underdetermination. Underdetermination. The prevailing theories fail to show why these values or of the parameters or the constants are what they are rather than something else. In this sense, these theories underdetermine the outcome. To such problems of underdetermination, there are in general three classes of solutions: the dialectic of chance and necessity, the view of our universe as one of a crowd of universes, and the appeal to historical explanation. Historical explanation includes the possibility that the laws of nature change in the course of time together with the phenomena that they govern. It is not just the content of the laws of nature that may change. It is also the law-like character of causal connection according to the thesis of causality without laws. The third class of solutions is merely undeveloped. Part of the program of this book is to develop it. The first two are irreparably defective Their flaws result from their failure to come to terms with the implications of the inclusive reality of time. Thus, the completion of our argument about the uniqueness of the universe and therefore of the advantages of succession, especially non-cyclic succession, or the plurality in our cosmological thinking, depends on the argument for the reality of time. The thesis of the singular existence of the universe and of the inclusive reality of time are intimately connected. It is nevertheless useful to sketch, even before working out the argument about time, reasons to reject both the dialectic of necessity and chance, and the conception of multiple universes as acceptable solutions to the problem presented by the unexplained parameters or constants of nature. We may be tempted to attribute the otherwise unexplained value of the parameters of nature to the effects of probability, the role of cosmic dice, it's a solution that becomes increasingly less satisfactory as we expand the scope of the explanatory work that we expect it to carry out. This approach may be useful in helping explain certain physical and biological events. Expanded, however, into a cosmological thesis, it is so incomplete as to be unavailing. It is the half rather than the whole of an answer, and it makes little sense without the missing half. To justify the metaphor of the dice, we must be able to say how such dice are put together and how they are cast, and within what setting of changeless or changing reality the cosmic gambling goes on. No wager sets its own terms. A probabilistic explanation can work within the framework determined in another way. Not when it is used to account for the most general framework of natural events. On this vast scale, to make use of probabilistic thinking is to replace one mystery with another. A yet more fundamental objection to the use of probability is that on the assumption of the singular existence of the universe, there is only one case of a universe at a time. The unexplained parameters are enduring attributes of nature in this one case. Such a circumstance violates the first requirement for the applicability of probabilistic reasoning. Probability demands a well-defined group. A second basic approach to the theoretical underdetermination of the parameters or constants lies in the appeal to a plurality of universes. This appeal, we have seen, can take two main forms. In one, macro form, it is the idea of parallel or divergent universes, the multiverse, of which our universe represents one. The thesis of plurality, in another microform, it is the notion of multiple states realized in different dimensions, a major theme of contemporary string theory. The macro idea pushes the laws of nature many levels up, assigning them the role of governing what is common to the multiple or parallel universes, rather than what is peculiar to the universe in which we find ourselves. The relation of the laws of nature to the unexplained parameters or constants would then resemble the relation of basic biochemical constraints and regularities to the relatively accidental path-dependent details of natural history. The micro-idea takes the concept of plural worlds many levels down into the multiplication of different ways in which the constituents of matter can interact. The way in which they do interact in the observed universe may then be explained as one of such possibilities. The possibility consistent with our own emergence. We shall then read the seemingly arbitrary constants in our own world as part of the indispensable background to our emergence, thus converting to our satisfaction arbitrariness into providence. In either of these two moods, the invocation of multiple universes amounts to an evasion rather than to an explanation of the mysterious factual residue in the present world view of science, manifest in the unexplained constants or parameters, as well as in the strange and finely tuned initial conditions of the universe. Such an invocation provides no account of why our universe is one of these many fanciful universes rather than another. The anthropic principle, which presents the values of the parameters or constants backwards. Very important. Backwards. Remember that. It's a helping tool. As part of the condition for our rise. Stands in for a missing explanation. The intellectual sin of this latitudinarian perspective is the transmutation of a scientific enigma into an ontological fantasy. Sorry. Ontological fantasy. The notion of the multiverse. Sorry, Tegmark and Hugh Everett. Under the weight of this transmutation, science sinks into allegory. The actual universe takes on some of the non-reality of the conjectural universes, so that the conjectural universes can borrow some of the reality of the one that we are in. The result is to rob the world of what, for science as well as for art, represents its most important attribute, that in all its present, past and future particularity, it is what it is or has been or will be, given its all decisive history. The real world is what it is, not something else. The more clearly we acknowledge this feature of nature, the deeper becomes in our ideas about the reality, the abyss between being and non-being. The conjectural worlds of the rejected allegory would provide the tertius between non-being and being, and make the contrast less absolute. The failure of these two ways of dealing with the factual residue, whether of the unexplained parameters and constants, or of the initial conditions of the universe, drives us to a third position. According to this third view, there is facticity because there is history. Because time is both real and inclusive. Here lies the connection between the singular existence of the universe and the inclusive reality of time. The phenomena change, and so do the laws. Causal connections exist in certain states of nature without the feature of recurrence and repetition that leads us to think of them as based upon laws of nature. The parameters that we observe in nature, some of them unexplained by the effective laws established by science, may, according to a conjecture suggested by such a view, be explained by the past of nature, the evolution of its regularities, as well as of its structure. Such a cosmology completes its turn into a historical science. To do so, however, it must abandon the war that physics, allied to mathematics, has long waged against full recognition of the reality of time. It must cease to rely on the idea of an immutable framework of natural laws. Four, the inclusive reality of time. The problem presented: how much of nature exists in time? Time is real, and everything that exists or has ever existed or will ever exist takes place in time. From these theses, there results the idea that the laws of nature must in principle be susceptible to change. Like everything else in this one real universe. They have a history. The inclusive reality of time is not a tautology or a truism. It is a revolutionary proposition, rightly and therefore radically understood. It is incompatible with the major element in the dominant tradition of modern science. The tradition that goes from Galileo and Newton to the particle physics of today. In particular, it contradicts the block universe picture of the universe as well as the application of the Newtonian paradigm. The explanatory practice that explores law-governed phenomena within a configuration space bounded by initial conditions to the universe as a whole. It puts pressure on our conventional notions of causality. It compels us to reconsider our beliefs about the possible and the new in nature. It suggests that the laws of nature are mutable and that the relation between laws of nature and states of affairs varies. It gives us reason fundamentally to invert the relation between historical and structural explanation in natural science, so that we may come to see the former as more fundamental than the latter, rather than as a derivative from it. The argument for the inclusive reality of time requires for its development and generates as one of its results a view of the nature of time. This view is in many respects incompatible with the prevalent understanding of what contemporary science has discovered about the universe and its history, but it is not incompatible with what science has actually discovered. What physics has found out about the workings of nature must be laboriously separated from the metaphysical pre-commitments in the light of which the significance of these findings is commonly interpreted. The reasoning of this chapter, as of this whole book, suggests not only a reinterpretation of the discoveries of science about the universe and its history, but also a redirection of the agenda of empirical inquiry and theoretical work in cosmology and physics. The physics of the 20th century undermine the views of space and time as an independent background to natural events. In so doing, however, it reaffirmed the idea of a backdrop of timeless natural laws. Poincaré and many others claimed that this idea was not only a matter of fact about the world, but also a requirement of the practice of science. It is a thesis of this book that the conception of an unchanging framework of natural laws must also be overturned if science is to advance. We cannot, however, overturn it within the limits of a way of thinking that treats time as an insubstantial extension of space. To carry out this overturning, we must come to an understanding of time as fundamental, non-emergent, and inclusive. Nothing is outside it, not even the laws of nature. Time is not emergent, although space may be. What a good way to end, I say. Thank you very much and have an excellent morning. Enjoy the last quarter of it. Tetarto. Mia tetarto para dodeca. Well, you can see sunshine here at least. And the beautiful flower of the November cactus. Amazing.